Hi and welcome to part 1 of the Boeing 737 Explained. This is our aircraft today and it's parked on stand 52 Alpha at Marseille. Today I'll be running through the pre-flight checks to set the aircraft up for a short flight from Marseille to Nice. As we set the various systems up for flight, I'll give a brief description of those systems and how they operate. So let's climb aboard and we'll make a start. Looking in at the flight deck, the controls and indicators that we're interested in today are located above the pilot's heads on the forward and the aft overhead panel. As this is the first flight of the day, we'll be doing some additional checks on the aft overhead panel. Before we can start, however, we need to apply electrical power to the aircraft, and the electrical controls are located on the forward overhead panel. If we take a closer look at the electrical control panel, you can see that it's actually comprised of 4 sub-panels. The first thing we need to do is switch on the batteries, and the battery switch is located in the bottom left-hand corner of the top sub-panel. There are 2 batteries on the aircraft, and they'll be capable of providing power for at least 1 hour. To switch the batteries on, simply put the switch to the on position and close the guard. If you now look up at the metering unit at the top of this sub-panel, you can see that the battery is providing DC power and it's also providing limited AC power to the standby AC system through a static inverter. Now that we've got battery power powering the DC system and part of the AC system, we need to power up the rest of the aircraft's electrical systems, and for this today we'll use the ground power unit that we saw earlier. The ground power panel is the 3rd sub-panel down, and as you can see there's a blue light which indicates that the ground power is plugged into the aeroplane, and it also indicates that the volts and frequencies of the ground power are of a suitable quality to connect up to the aeroplane without doing damage to the electrical system. So if we move the spring-loaded switch down, it'll connect up the ground power to the AC systems and the aircraft is now being fully powered up. We can now continue with the pre-flight checks, starting off with the aft overhead panel. These checks on the aft overhead panel are normally only completed before the first flight of the day. We'll start the checks on this panel on the right hand side with the overspeed warning test. If the aircraft exceeds its maximum Mach number or maximum indicated airspeed, then warning clackers will sound to warn the pilots. These buttons are used to test the overspeed warning system. Okay, after that check then we can move to the left and you can see the flight recorder test switch. The flight recorder, or black box, records thousands of parameters of the aircraft whilst it's in flight. And it's used by accident investigators to determine events leading up to an aircraft accident or an aircraft serious incident. The flight recorder starts to record during the first engine start, and it's activated by the oil pressure switch on that engine. So at the moment, as you can see, there's an off light on. Moving the switch to the test position bypasses the oil pressure switch, allowing the flight recorder to start to record and the off light goes out. So that's all you need to do on that test. Then just return the cover to the down position, switch will return to normal, and the flight recorder, with the engines not working, will be off. We can now move down to the stall warning test, and activation of the stick shaker when pressing these buttons indicates the correct functioning of the stall warning system. So if we press the number 1 button, you should be able to hear the control column shaking, and if you look down you'll see it moving. And we'll test the number 2. It's worth bearing in mind that this particular test won't operate for around about 4 minutes after applying power to the aircraft. So if you apply the power and then you're fairly quick getting around to this test, you might find it doesn't work, in which case just wait for a while and then repeat the test. Okay, so moving on, the next column at the top there's a combined communications unit, and that's for use by the crew member on the jump seat, so there's no checks to do with that. Underneath the combined communications unit are the engine electronic controls. The panel that controls them has got 2 reverser lights at the top, 2 engine electronic control switches underneath, and either side of each switch there is an engine control light which will illuminate amber in the event of a failure of the electronic control. The reverser lights at the top of this panel will illuminate amber for approximately 10 seconds during reverser stowage after a normal landing. If the reverser sleeves fail to stow, then the appropriate light will remain on, and that will be accompanied by a master caution eng, and you can normally stow the reverser simply by lifting the reverse lever up to reverse idle and then restowing it. Underneath the reverser lights are the switches that control the mode of operation of the engine electronic controls. If working correctly, these will have on in the centre of the switch surrounded by a white circle. If the switch is blank, then it shows that the electronic control has failed for some reason, which will obviously need to be investigated. And if you see alternate showing in the switch, that indicates that the normal system has failed and it's working in an alternate and reduced mode. The aircraft can be dispatched with the ECs working in alternate mode, but if that is the case, then both of the systems have to be switched to alternate. For the pre-flight check, make sure that all the lights are out and that the white on is showing in the middle of the EC switches. Underneath the engine control panel, there is a panel for passenger and crew emergency oxygen. This is oxygen that will be used in the event of a pressurization failure. Passenger oxygen is supplied by a chemical reaction from an oxygen generator which is housed in the overhead panel above the passengers' heads, and there's one oxygen generator for each passenger, and the oxygen is supplied to the passenger through an oxygen mask which is stowed next to the oxygen generator in the overhead panel. Following a pressurization failure, and at a cabin altitude of 10,000 feet, the crew will be alerted by an intermittent horn, and the emergency drill will direct them to switch the passenger oxygen switch on. The act of doing that will then deploy the masks. At the same time, the passenger oxygen on light will illuminate. If for some reason that switch isn't operated at 10,000 feet, then the masks will automatically deploy at a cabin altitude of 14,000 feet. To the left of the passenger oxygen switch is the crew oxygen gauge. Crew oxygen is stored as liquid oxygen in a tank in the forward hold, and this is supplied to each crew member through a mask at the crew member station on the flight deck. There's a minimum pressure for dispatch which depends upon the temperature of the liquid oxygen in the tank and the number of crew who will be breathing the oxygen. A table, normally kept in the minimum equipment list, will give the minimum pressure required for dispatch. Underneath the controls for the emergency oxygen systems are three green gear down lights. These are repeaters from the lights on the main panel, and they're used in the event of a light failure on the main gear indications to confirm that landing gear is down and locked. Moving on from there, we go to the middle of the panel, and you can see there are two switches on this part of the panel. The top one, which is labelled service interphone, is not used by the flight deck, it's used by maintenance personnel, and it's a system whereby maintenance personnel can speak to the flight deck from various points around the aircraft whilst completing their maintenance tasks. This system isn't used by the crew, and so this should be switched off. Underneath that is the dome light switch. The dome light is powered by the battery, so providing the battery is on, you should be able to get some illumination on the flight deck. If you look at the top right hand side of the overhead panel, you can see there's the dome light there. There are actually two dome lights, one there and one at the rear of the flight deck. So if you switch the 3-position switch up, you can see the dome light is illuminated dim, and if we put it down, you can see the dome light illuminates bright. So for this check, normally you'd have the dome light off. To the left again, you can see the IRS control panel. There are quite a few checks to be done on that, and I'll come back to that once we've finished off the rest of the items on the aft overhead panel. So we'll move across to the left again, and you can see there's the emergency locator transmitter, or the ELT, and this will transmit a recognisable signal on the emergency frequencies of 121.5, 243 or 406 MHz in the event that the aircraft is subjected to a high G loading, or if the switch is placed in the on position. For this check though, you just need to make sure that the guard is down and that the light is off. Underneath the ELT control panel is a leading edge devices annunciator. The wing on the Boeing 737 is designed to be at its most efficient when flying at high speed and high altitude, and to improve its low speed efficiency, it's fitted not only with trailing edge flaps but also with leading edge high lift devices. These consist of 4 slats on each wing and 2 Kruger flaps fitted inboard of the engines. The leading edge devices improve the efficiency of the wing at low speed by increasing the wing camber and also increasing the wing area. The movement and position of the leading edge devices is indicated to the pilot by the two lights underneath the flap gauge on the main instrument panel. The leading edge flaps have got one extended position. The leading edge slats have got an extended and a fully extended position. When the trailing edge flaps are selected to a flap setting up to 5 for takeoff, the leading edge flap's transit light will illuminate as the leading edge devices start to extend. Once they're in the selected position, the leading edge flap's extended light will come on. If I now select a flap selection higher than 5, a selection that will be used for landing, you'll note that first of all the leading edge flap's transit light will come on as the leading edge slats extend further to their fully extended position, and then once they've reached the fully extended position, the leading edge flap's extended light will come on. If one or more of the leading edge devices either fails to move or fails to reach its selected position, then the leading edge flap's transit light will remain illuminated. In this case, the non-normal checklist will draw the pilot's attention to the annunciator on the aft overhead panel, where an individual amber light will indicate which of the devices has failed. During the pre-flight check, it's just necessary to press the test button and ensure that all of the lights illuminate. Okay, so that's the items on the aft overhead panel just about completed. So now I'd like to move on to look at the IRS systems fitted to the aeroplane. There are two independent IRSs installed on the aircraft. Each of these IRSs has got 3 laser gyros and 3 accelerometers, and they are the sole source of attitude and heading information on the aircraft, apart from the standby instrumentation. The heart of the systems are 2 ADIRUs, or Air Data Inertial Reference Units, and they combine the detected inertial information with air data information to provide inertial position and track data to the FMC, and the attitude, altitude and airspeed data to the common display system for flight instruments. The IRSs are controlled from this panel here, the IRS control panel. At the top of the control panel is the IRS display unit. This has a screen at the top. Underneath the screen is a rotary switch which can be used to select data to display on the screen, and this data can be either true track and ground speed, present position in latitude and longitude, wind speed and direction in degrees true, and the heading and status, which will show the number of minutes left to full alignment. Underneath the display selector is the system display switch, which selects data from either the left hand or the right hand IRS for display. To the right of these is a small keypad, and that can be used to enter either the present position in lat and long or the aircraft magnetic heading. Underneath the IRS display unit is the mode control unit. You can see that has got 2 rotary switches for selecting the mode for the IRS to operate in, and above those 2 switches there are a series of lights. The GPS light at the top will illuminate on recall if one of the GPS systems fails, and it will illuminate permanently if both of the GPS systems fail. Underneath the GPS light there are 2 sets of 4 lights. The white align light indicates that the IRS is in the align mode when it's illuminated steady. If it's flashing, then it indicates that alignment cannot be completed due either to detection of a significant difference between the previous and entered positions, or no present position has been entered. Next to that, the on DC light will indicate that the IRS is operating on DC from the battery instead of its normal AC power. If that happens, the right hand IRS will be switched off after 5 minutes to save battery power. If the aircraft is on the ground, then the ground call horn in the nose wheel well will sound, providing an alert that a battery drain condition may exist. Underneath the on DC light you can see there's a DC fail light, and that indicates that the DC power for the IRS isn't normal. If however all the other lights are extinguished, then the IRSs are still being powered by the AC system. Finally, the fault light will indicate there's a fault which affects the IRS attitude and or navigation. Underneath the lights there are 2 rotary switches which are used to select the mode of operation for the IRS. In order to start the IRSs aligning, we need to switch them through the alignment mode to the navigation mode. So if we start with the left hand one, onto align and navigation. Note that the on DC light comes on for 5 seconds as a test of the DC system, and then 10 seconds after selecting align the align light will come on. The align light will remain on until the IRS has finished alignment and enters the navigation mode. And as we've selected navigation, it will automatically go into the navigation mode once the IRSs are aligned. And when that happens, the align light will go out. So we can do the same for the right hand IRS, select align, the on DC light comes on momentarily, and then we'll switch it to nav so that it'll automatically go to navigation mode once alignment is completed. The alignment process can take between 2 and 18 minutes dependent on the latitude of the aircraft. The number of minutes left to full alignment can be displayed on the IRS display by switching the display selector to heading and status. That completes the checks on the IRS control panel, but to achieve full alignment we now have to enter the aircraft's present position. This can be done on the small keypad on the control panel, but is more normally done using the CDU or control display unit, which is located at the forward end of the centre pedestal. There are two identical units fitted, one on the left for the captain, one on the right for the first officer. The CDU is the interface between the pilots and the flight management computer. It comprises a screen at the top which can hold up to 6 lines of data, which can be displayed either on the left hand side or the right hand side of the screen. Either side of the screen you can see there are 6 keys. These are called line select keys. Line select keys are used to either enter data into the FMC or to select data for use elsewhere in the FMC. The bottom line of the screen is known as the scratch pad. This is where data entered into the keypad for entry into the FMC will be initially displayed. It's where data that's been selected from the FMC for use elsewhere will also be displayed, as will messages relating to the FMC, as here where it says enter IRS position. Underneath the screen is a keypad. The top keys have got pre-assigned functions, and underneath those are alphanumeric keys used to enter information into the scratch pad and from there into the FMC. We now need to enter the aircraft's present position into the IRSs. Before we do that, we'll just clear the message in the scratch pad by pressing the clear key on the bottom right hand side of the keyboard. And we need now to select FMC. So if we press the line select key one left, you will see that that will then bring up the first page that we require. That's the ident page. The ident page contains information about the aircraft, the nav database, and the update for the FMC. There's also a section for any supplementary data, and at the bottom of the screen you'll see that there are 2 prompts. One will take you back to the previous section, and the right hand one will take you forward to the next section, in this case the position initialization section. So in order to set the IRS position, we need to select the POSINIT page by pressing the line select key 6 right, and this will then bring us on to the POSINIT or position initialization page. And we can see that this is page 1 of 3. On the first line of the data you can see it's got the last position entered. Underneath that it says reference airport, and you'll note that that has got dash lines which indicate that it's advisory data. Conversely, the square boxes indicate data that has to be entered, as in the set IRS position here. So although we don't have to enter the reference airport position, for completeness on this case we will, and we're in Marseille, which is LFML, which initially goes into the scratch pad, and we'll then line select it into line 2 left. And you'll see on the left hand side it gives you the ICAO reference for the airport, and on the right hand side it will give you the Latin long of the reference airport. One thing to note is that the Latin long for the reference airport slightly differs from the last position. The reason for this is that the last position will be the gate where the aircraft was shut down, and the airport reference point is normally around about the middle of the airfield. There are a number of ways we can enter the aircraft position into the IRSs. We could use the aircraft's last position, we could use the reference airport position, we could manually enter the aircraft's position into the square boxes. The most accurate position, however, will be provided by the aircraft's GPS system. In order to find the GPS position, we need to go to the POSINIT page 2. There's a function key for next page. If we press that, that will then bring us onto the position reference page. The 3 positions at the top are FMC and 2 IRS positions. They're blank at the moment because we've not yet entered anything into the IRS. However, underneath those there are two GPS positions. It's GPS left and GPS right. They're both identical, so if we select one of them, we'll go for GPS left and we'll select it into the scratch pad. We now need to enter it into the IRS, so if we go back down to our function keys, you can see we've got previous page, so we'll press that. The GPS position is still in the scratch pad, and in order to set that into the IRS, we can now line select it up to 4 right, and that will then bring that position up into the square boxes. Once the IRSs have completed their alignment, then that set IRS position will disappear. So if we select that position up, it goes into the square boxes. When the IRS has finished its alignment, as you can see, that position disappears. And if we now look up at the instruments, you can see that they are now displaying. They're being fed by information from the now aligned IRSs. And if we go back up to the IRS panel, you'll note first of all the align lights have gone out, and if we just check the present position, you'll see that the position we entered from the GPS is now entered into the IRSs. Okay, so that's the IRSs fully aligned. They're in the navigation mode, and we can now continue with the rest of the pre-flight checks. Next time we'll have a look at the pre-flight checks on the forward overhead panel. We'll have a look at the mode control panel, or the MCP. I'll explain the use of the FMAs, the flight mode annunciators, and we'll program the FMC for the short flight from Marseille through to Nice. Thanks for watching today. I hope you enjoyed the video, and I hope it will be of some use to you. As well as these main videos, I'm also going to produce some 737 short videos, and the first one of those will cover the takeoff technique for the Boeing 737. Happy flying, and I look forward to seeing you again soon. or and we'll also look at setting up the mode control panel.